the specs are really confusing on this, but basically they set the start time and the end time as the entire range, rather than the start time and the end time as the initial meeting, and then made it repeat.
Yeah, so apparently he did that, but the thing is, apparently he fixed that in Google, but for some reason in the feed, in the iCal feed, something is still wonky, so that Apple's calendar app is still displaying it wrong. And so there's actually no way to fix it. And David kept saying, oh, just unsubscribe and resubscribe, but that only fixes it for like 10 minutes, and then it comes back.
Hey there.
Right. Hey.
Hello.
Hello. Hi. We're live. Hi. Hey, I see Hannah. I see Terry. I see a lot of people. I'm not going to go through all the names. Let's begin. Hello, my name is Portia, and welcome to the IPFS All Hands On call. This the call where you get a chance to listen to some of the exciting projects happening in
Is it just Portia frozen?
Yeah, she's frozen for me too.
Okay, all right.
Yeah.
Portia, we missed you. You're gone.
Yeah.
Presumably, you'd like to introduce our speaker of the day, Michael Rogers, talking about a thing, which he'll tell us what he's talking about.
Hey. Hey everybody. Should I wait for Portia to come back, or should I get on with it?
Maybe you could just introduce yourself.
Yes, I am Michael Rogers. I work on lots of things. Yeah. So this talk. Okay,
wait a second. My internet cut out for a moment. Before we begin with the talk, we will start with announcements.
Okay,
so,
cool.
Does anyone have announcements? Let's check. I don't see any announcements, so let us begin with the presentation then.
Molly was raising her hand.
I was just going to remind
sorry,
everyone from David's point from last week's call that everyone who's participating in OKRs, please make sure you're scoring your mid-quarter OKRs. We do it asynchronously, but it helps us keep track of all of the awesome initiatives that are making progress and which things we need to put more wood behind so we can get them done before the end of the quarter. So thanks to everyone for spending some time on that this week.
Thanks, Molly. Anyone else? Any hands? Okay, let's begin.
Okay. Hey, yeah. Oh, yeah, you can introduce it. Oh, sorry.
Yeah. So welcome, Michael Rogers. And we are going to listen to your presentation, which is called The Internet of Data.
Cool. Yeah. Okay. So just some quick background while I get the slideshow working. So do full screen. Yeah. So often like way in advance, I have to like commit to what a topic is for a particular talk. And so this was like 4 months ago or so, maybe 5, when I had to commit to Cascadia. And so I decided that I was going to try and give a talk that was basically taking our vision for the next version of the decentralized web and trying to boil it down into something that like everyday web developers could understand, and create sort of a narrative of like why that's important, and sort of some of the primitives in our view of kind of content addressing as a way to really open up some things that you can't do right now on the web. So that's this presentation. Can y'all see it?
Yes.
Oh, I bet things are getting blocked though. Okay, do you see, okay, and you don't see the Zoom tools. Cool, okay, awesome. All right, so yeah, so that talk was called The Future of the Web, Vision for an Internet of Data. I think for this audience, Internet of Data is probably a little bit better. So anyway, that's me. All right, so we start with back in the 90s. Even though this is a future talk, we need to kind of start back at the beginning. So if you roll back to the mid 90s, you'll see that there was a real fight for the future of the web. Actually, just the future of the internet. There wasn't really a dominant application platform for the internet yet. And what there was like a bunch of kind of content portals. AOL is the most notable one, but there was this vision of the internet as basically being a way for individual consumers to connect with different people's corporate content portals. And that like this was like what Bill Gates used to refer to this as the information superhighway. That was actually like a different thesis for what businesses would look like on the internet. And then there was this thing called the web. And if you're looking at both of them kind of side by side here, like one is a lot nicer to use than the other. like a lot of things about AOL were much better. Like all the content in there is like professional. There is a taxonomy that makes sense. You can find things. And just like, you know, like if somebody wants to tell me about something on the web versus on AOL, like Oprah every day on her show would be like, go to keyword Oprah in AOL. Just type in Oprah and you'll see all of my content and everything that we put out professionally. And on the web, it was like, oh, I have a page about Oprah. It's like http:// and then like literally, like you had to type all that in. The browser wasn't smart enough yet to do that for you. So there's like from a consumer standpoint, one of these was significantly worse in terms of experience. But as we know, like the web won, and the reason that the web won was that we had URLs and links essentially. So the starting point for putting content onto AOL was like get a keyword. So that was like, you know, be Oprah. Like if you're Oprah, you can get keyword Oprah, but if you're not, you like can't really put content into AOL very easily. On the web, like everybody could create a website and put up these really ugly URLs. And then most importantly, everybody else could link to those URLs. You have this universal way to connect everything together. And so when I create like my Oprah blog, even though blogs didn't exist back then, but if I created an Oprah blog, like, you know, somebody's favorites page could point to it and somebody could create a web ring and other people start creating content. And eventually what we get is, you know, this huge mesh of content that is all interlinked. And so when we're comparing, like, you know, you can't really compare like my blog or my favorites or any individual page to like the professional Oprah content on AOL. But when you took like this huge network of content and the cumulative value of that network of content, it was like actually incomparable to the AOL content. It was just so massive and so valuable. And then when you take this little section of Oprah content and you put it all together, like the web ends up being this unbelievably valuable, huge network. And because of those network effects, you're comparing something much more valuable to that content portal AOL. And of course, like this is growing exponentially at the time and still. And so part of the value here is the network, not any individual piece of the network, right? Okay, so the web is like built on the network effects of links. Like in the modern era, when we talk about the web, instinctively developers think about, you know, standards and web frameworks and JavaScript and all this stuff. But like you really have to go back to the beginning to realize like the foundational building blocks here are links and URLs. So let's look at links and URLs. So an URL has a transport, which is like, so actually let's go backwards. So let's start with content. So you have like a named value for a content, like you either make it the index of a particular page or you say like, this is the name of a page. Then there's an authority. So you told me what the name of this content is, who do I ask for the content? And then when I ask them, they'll tell me, oh, this name belongs to this particular piece of content. And there's a transport, which is how I go and ask that authority for that content. And this is like how content is addressed on the web today. So that's problematic because you'll notice that like centralization is baked in. The network as a whole, like the entire web, is federated because anybody can put these up, but actual URLs are centralized. You have to talk to a particular location. And this applies to more than just the HTML for that content. To some extent, HTML and static assets aren't really a big problem. Like when I pull up twitter.com or facebook.com, I can and do really manipulate that page because once it's in the browser and it's part of the open web, I can remove ads. I can like change words like that stress me out like Trump to words that don't, like daisies. Like you can literally do that in the browser. It's amazing. But the web and web applications are much more than static assets. Like modern web applications pull a ton of their content and information in dynamically from web services. And these web services are all like addressed by these URLs, so they are centralized. And so what you end up getting is like data centralization kind of baked in. Even though you can talk to multiple services and like I can pull in the content from anywhere, anybody can put up a website. If I want to have relationships between two pieces of data, I have to put that in a content silo behind an API. And the thing about this is that there's no good way right now to not build this way. If I want to make a multi-user application, I essentially have to go and build a data silo. So like every web developer right now who cares about a lot of the problems on the internet still has to like make a decision and go and build an application and effectively build it the same way that we always have. And so this drives costs for applications because you have to have like this huge content or this huge like data silo. One of the early talks at Cascadia was on cloud functions, and it's literally like pennies to run like 1 million function executions or something. And but if you start just logging a little bit of data in those functions, your bill will just get massive because storage is not cheap, is not pennies per execution, and it only grows over time. So because applications cost money to build, especially multi-user applications, that's where we have to basically create ad-driven business models. Ad businesses are the primary business on the web because in order to participate in those network effects that we saw before, you essentially have to have the content open to the public and linkable. And so having content behind some kind of paywall makes it very, very hard to participate in the network effects. So that really incentivizes people to create ad-driven business models. And what we've seen now is that on a long enough timeline, these ad models like start adding machine learning and better algorithms, and they learn. And what they learn is that the best way to continue to attract our attention is to push us towards more and more extreme content. And so essentially like radicalization is sort of like the end state of ad-driven business models on the web. It's what they inevitably get to because it is just the most efficient way to make us all watch YouTube all day. And we have like, unlike, static assets that get loaded in the browser that you can manipulate, we have like no visibility into these algorithms. We can't change the data that comes out of them. They just don't participate in the open web in the way that, the rest of the resources that are standardized do. Okay, so like to break this down a little bit more, like you have a web application that talks to multiple APIs. All those APIs talk to different databases, right? So if we want to get rid of just this API layer that is so problematic, we have to look at what we might need to connect to or what we might need to replace. And once you start to drill into this, what these databases do is they take data structures in some kind of serialized form, and then they actually serialize them again to disk, or often to a network of servers that are actually writing them to disk, and they provide certain consistency guarantees both on the read and write end. And it's hard if you haven't done database engineering to really understand, but API calls that users make when they make just very simple APIs really depend on and take for granted the consistency guarantees of these data structures and databases. There are literally sort of on-disk guarantees at like the fsync layer in a lot of databases that bubble all the way up to the end of an API call. And if you want to start replacing the APIs, you literally have to go all the way down and start to think about, okay, what do we do when we take a data structure in memory and it has to leave memory? It has to be shared out with other people, or it has to be written to disk for long-term storage. Like that part of things has to be completely rethought from scratch in order to actually solve this problem, because that part needs to be decentralized. It needs to work outside of a data silo. So if we come back to the URL, we have to get rid of all of this because we can't be asking for particular authorities for content anymore. And it turns out that another thing that an authority does is that it creates like a de facto namespace, right? Because since I'm asking that authority, I can assign these human readable names to everything. And then that authority says, if this is the latest version of that or not. So we kind of have to get rid of that. If we have like a global decentralized network, we're not going to have this namespace on a website anymore. And so we essentially can hash the content. And this is where we start to get into a larger view of hashing. Hashing has been around for a very, very long time, but it seems like all the time we're figuring out new ways to work with hashed content, new primitives that we can build on top of hashing. It's an incredibly powerful concept. And I promise I'm not going to talk about blockchain. That's an important part of this talk, that we don't say blockchain. So this is content addressability, basically. If rather than referring to things by URLs or human readable names that we create, if we instead say, okay, the way that we're going to refer to data is by the hash of that data, then we get some really interesting benefits out of that. One is that like this primitive doesn't require us to centralize the data. Data can come from anywhere, and we have a way cryptographically to verify that we are talking about the same data and that I got the right data. So this proof is really important because it really liberates us from having to talk to an authority or do some kind of access control or like, authentication dance. Because if I have the hash of data and I get it from literally anybody over any transport, it doesn't matter how I get it. I can verify that that data is the data that I needed, that we were talking about the same thing. Okay, so to give like a very kind of high level view of what this looks like in sort of a pseudocode, at Protocol Labs, we have a primitive called CID or content ID, which is a hash with like a little bit of extra data in front of it that tells you how to interpret it and how to pull additional links out of it. So if I published a blog, I would have like the title of that blog and some posts, and then those would essentially have CIDs in them that are links to that content in the centralized network. And so then I would say, oh, hey, yeah, I need to go get that hash now. And I literally get this hash from anywhere, anybody, any transport. I could have it in a local cache indefinitely offline. I could have it in a local network that's not even connected to the internet. I could grab it out of a peer-to-peer network. I could get it out of a CDN. Any way that is the fastest and simplest way to get this content, doesn't matter how I get it. And then, of course, if Sally creates a list of her favorite blogs, she can link to my blog because there's this universal identifier. Just like in URL, like these hashes end up becoming universal identifiers on a global internet. And Heather can create an aggregator that also points at my blog. And so you can see how we're starting to build the same sort of network effects of URLs and links for web applications and content at the actual data layer, at a much more primitive layer. And the interesting thing about this is that each of these actors can be hosting this content in completely different locations. So just like on the web, not all the websites are in the same place, but we can still link to each other and create a network of value. And here we actually have data structures like this aggregator points to the data in my blog directly, but somebody else is hosting it. Or maybe I'm hosting all of this. I pulled it all into a local cache to work offline. All of that works. And we don't have to change the data structure. We don't have to do any kind of extra dance. This is, I've done offline stuff for a really long time. This is really interesting where you can actually stop thinking about authenticating to a place and then in your offline cache saying, oh, well, this is like the authenticated data that I got from this particular location. You don't have to keep any kind of reference around for how you got that data. It doesn't really matter. It's all just a hash. So for like a more realistic use case, so universities publish genomics data. It's a huge amount of data. And then if I want to create do regression, I want to take a collection of all of their data, point at it, and go and do that regression. So with these primitives, I wouldn't have to host all that data locally and turn it into a single format. I could literally create a new data structure that pointed at all of the data structures that the people are publishing, and it'll go and pull them out from either directly from these universities where they're hosting them, or from mirrors if that's faster, literally anywhere that would have the data. And then the results of that regression can point again directly into the subparts of that those data structures where we find the things that we're looking for. And again, I don't have to be hosting all of these little individual leaf nodes of data. I can create a very big, robust data structure and only actually store or continue to publish and keep alive a very small amount of that data, since it's basically available on this global web. Just like if I link to a website, I don't have to host all of those websites indefinitely. Similarly, like if I were going to recreate Twitter, right? Like everybody, like Bob and Alice and Sally and Heather are all just publishing their Twitter data, and my feed just points to all of their feeds. And my favorites is just pointing to each of their individual favorites. And this looks the same as the prior example because it's the same primitives. It's just CIDs, but these are very different data structures. The actual data underneath would look really differently. But with this primitive content addressing, we can start to solve these sort of global data distribution issues. So a CID is like a pointer that spans the internet. That's a really important concept, right? Like we don't usually think about URLs as pointers, but if we start to think of CIDs, or if we start to think of URLs as pointers or CIDs as pointers, you can start to imagine how to build a B tree. Like if you ever had to do that Google interview and then never use any of that data again, you can actually build these fancy data structures that are very big. and we can start to recreate what databases do in a very siloed, centralized way for the web. And this is a quote this is my quote, I said this. But actually, after I said, this is funny, this is just for this audience, I didn't say this at Cascadia. The first time I said this out loud was at Juan's house with Stephen, and right afterwards, Stephen corrected me and said, no, they're like pointers in Rust because they can only be forward. I was like, that's true. Okay. Anyway, okay. All right, but the end state here is that we, again, we create something like the web for data. We can start to, like, as we start to create, the next big application, like the size of Twitter or Facebook, these big multi-user applications, if we start to build them on these primitives, then the data is going to end up having access to the same kinds of network effects that the web has access to. Because all of a sudden, like, my tweet data is incredibly open and linkable and usable by all of these different use cases that I never thought about. And people can build new applications and new value on top of them, and we can start to create in the value of the network. And so when people start to make these comparisons about, like, oh, well, what is a good use case for these primitives, or what is, like, the thing that we're not doing, implying that, like, everything that we've done so far is the right way to do things, and that there's a new set of things that we need to do that you're solving for. But if you just, like, recreated Twitter, recreated Facebook, or something like that, and it could participate in the network effects of this data, we'd blow, Twitter and Facebook out of the water, because the value of that data is so much more valuable than, like, to the public and to everybody, than Twitter or Facebook, because it is not locked up in this content silo. Like, we basically start to create this internet of data, and that's what we want to push for. And so, yeah, so we're working on this in IPLD. We're running some new specs. We're literally in the earliest stages possible of this. So we are examining, like, fundamental data structures and starting to rebuild some of those and having some really good discussions. So if you're really interested, go and check this out. And that's the talk. Hopefully that was shorter than the talk that I gave at Cascadia, because it was going really fast. Oh. How do I stop sharing? Did I stop sharing?
It's at the top of your screen.
There we go. There we go. There's a button. Okay. Is it question time?
A round of applause. Woo! Yeah.
Yeah. So I think that, like, I mean, this is not a lot of new information
Definitely is
for
question
this
time.
audience. Yeah, I think that this wasn't a lot of new information for this audience, but it's really, like, trying to talk to web developers and bring them in and show them the value without saying the word Merkle-DAG or blockchain, or even, like, peer-to-peer isn't really a big part of this, right? Like, because peer-to-peer is, like, it's really exciting for us, and I'm still really excited about peer-to-peer, but a lot, when we say it, especially in web developer audiences, they start to think about it as, like, this niche thing, where it's like, oh, there's this section of peer-to-peer apps that people are going to build that are separate from the rest of what web developers are doing. And that's kind of what I'm trying to break out of. So hopefully that's working. But yeah, the talk was really well received, so that's good. Questions?
I have a question or suggestion. In terms of, like, the relationship with blockchain, I think it's almost better to talk about blockchain and declare this is not explaining blockchains. This is explaining some technical principles that blockchains do use, but you could use them too. And, like, make that case, because I think a lot of people are curious. They want to know more about blockchain. So showing, like, hey, this is connecting with that domain, but it's just using the parts that are useful without committing to a whole, like, mindset of something that might be a fad.
Yeah, I mean, so obviously, like, a lot of people that are familiar with content addressing are familiar with blockchain. Like, that's how they're familiar with it. I think that the hard thing to break them out of is that they think of content addressing in like a siloed, almost namespace way, right? Where it's like, oh, this is a great way to address content, like, in the blockchain network, in the Bitcoin network, or in the Ethereum network. And we're thinking about it much more globally. Like, this is a way to address content, like, in, every blockchain ever, and, the entire internet. And so that's kind of why I've started from scratch to kind of and also most people in a web developer audience aren't familiar with content addressing. But yeah, I did. So after some of the follow-up conversations, I did end up realizing that at some point you probably need to work in something about blockchain, because somebody was literally asking me like, oh, well, like, how would you, create like a history of changes to that data structure and then like always get the new one in like a chain. And I was like, you literally just described like a blockchain. So yeah, that was pretty funny. So yeah, I agree. Like there needs to be some kind of way to, at some point you need to show like, oh, this is the primitive that you also use for blockchain.
Any other questions?
Hey,
hello?
I was wondering, do you feel it's, or how important is it in the sort of the intro talk stage versus later on as they get, more in depth to discuss sort of the difference between, we'll call it like paying for everything and things being free? Both from sort of in both directions, both the fact that we get everything for free because of ads, but also and in a decentralized way, maybe it's a little different. And the opposite, where the peer-to-peer network means you're relying on some sort of benevolence of the masses to help you get the pointers around. Whereas, DNS operates differently.
So one of the things that I specifically wanted to avoid was talking about how you get this data, because it's honestly like a big kind of question mark. Like we have ways that we're currently pushing around this data, but you could take all of the blocks ever and put them into a centralized block store and just only talk to that. Like that is actually a possibility, right? And like I know that Google has people like looking at decentralized web technology and starting to build indexes around it, and what they're probably doing is just taking all of the hashes ever and putting them into a giant centralized store, and then examining the links of them. And so I think that like once we have a real flow for people to make some structured data and then publish it and host it, and we have a whole workflow around that where, here's how you host it by yourself indefinitely, here's how you pay somebody else to host it. Once we have that workflow, then we can start to talk about how people get it and how they keep it alive indefinitely and what the cost structure is for that. But like until we're literally demoing that flow, I would rather not start to get into those issues, right? Okay, looking at the chat queue now, because that's what we're doing now. Johnny Crunch, you're up.
Yeah, so I've been involved in the W3C recently, and been a bit frustrated because they have very much URL focused view of the world. So if there were to be standards, they imply standards bodies. So where do you see this work going for what standards bodies to push this forward?
So obviously things are really early, so we want to make sure that we don't try to standardize too early. That said, like there are some parts of our stack that we know aren't changing, right? Like multi-hash is not changing. And if it is, like that would be like a big breaking change and effectively like a new standard. So there's some low-level stuff that we do want to start to get on a standards track, but probably not at the W3C, at the IETF instead. The IETF is just like a bit easier to work with for a whole variety of reasons. And a lot of like web standards are at the IETF, by the way. So it's not like out of the realm of like, yeah, only a section of web standards, mostly all the DOM stuff is only at the W3C/WWG. Like HTTP2, most cryptography stuff is all like at the IETF. So it kind of makes sense for us to go that route. But yeah, I have a call like this week with somebody that we may be working with to try to help us get this, some of the multi-format stuff on a standards track.
Okay, and Hannah will have the last question.
Hey, I'm just curious if you got any questions about private data, authenticated data, just because I, as someone who normally builds web applications when I'm not working on IPFS, most things tend to have an authentication system and then privatized data.
Yeah. I think that the analogous part of that story for for my talk, like people did ask about that afterwards. And I just said like, you need to encrypt the data, like frankly, like the issue with having like globally addressable structures that literally can last and be archived forever is that we can't take plain text data and put it behind an authentication mechanism, even if that's the only way to get at the data for now, because anybody could pull that out and then make it globally addressable, and then that would just work literally afterwards. So you need to encrypt your data if you want to keep it private, and that's like a best practice that we need to move for generally. And then if you want to share data and have work groups and user flows and all of that kind of stuff, like you need to figure out how you're going to do the key management in order to solve that. So these are all sort of solutions that you layer on top of. David asked if the Cascadia version is available online already. It's not yet. So they did the whole conference at Amazon, and Amazon handled all of the AV and everything. And so I talked to Carter about it, and they are going to give the talks to Carter after they're done editing them. He doesn't know what that timeline is, but afterwards, then they'll go onto YouTube.
Okay, excellent. That concludes our presentation. And before we log off, I was having problems with my Wi-Fi connection, so I am sorry if you were not able, if it's cut out. So I'll be sure to address that problem for next week. Thank you very much, and I'll see you next week. Bye.